We've all dreamed about it. The idea that somewhere out there, an advanced alien civilization is watching us, perhaps even holding Earth in its grasp like a puppet. In our minds, these beings are colossal, mysterious, and powerful, controlling the fate of our planet from the shadows. But then, we wake up. The fantasy fades, and we're left with the reality that the aliens we seek might not be towering overlords. Instead, they could be small, perhaps even microscopic, quietly thriving in the harsh environments of our neighboring worlds. You're moving forward through the cosmos, searching for signs of life. But what if the answer to one of humanity's greatest questions is closer than you think? Could life be lurking just beyond our earthly neighborhood? Let's explore the possibilities. Let's take a moment to consider the incredible resilience of life right here on Earth. Extremophiles, organisms that thrive in conditions that would be lethal to most life forms, show us that life can adapt to some of the harshest environments imaginable. Take, for example, the tardigrade, often called the water bear, a microscopic creature that can survive in the vacuum of space, endure extreme radiation, and even go without water for years. Then there are thermophiles, bacteria that thrive in temperatures that would cook most other organisms, and acidophiles that live in environments with pH levels close to zero. But it doesn't stop there. Consider the hyperthermophiles, which thrive in environments with temperatures exceeding 80 degrees Celsius, 176 degrees Fahrenheit, such as deep-sea hydrothermal vents. These organisms don't just survive, they flourish in conditions that mimic the hellish environments we might find on other planets or moons. Then we have barophiles, organisms that have adapted to the crushing pressures found deep within the Earth's oceans, where the pressure can be over 1,000 times greater than at sea level. These extremophiles expand our understanding of the limits of life and suggest that where there is energy, life finds a way. Their existence challenges our notions of what is necessary for life to thrive and opens up the possibility that life on other worlds might be similarly adapted to extreme conditions we once thought impossible for living organisms. These extremophiles expand our understanding of the limits of life and suggest that where there is energy, life finds a way. Their existence challenges our notions of what is necessary for life to thrive and opens up the possibility that life on other worlds might be similarly adapted to extreme conditions we once thought impossible for living organisms. For decades, we've gazed up at the stars wondering if we're alone in the universe. But maybe, just maybe, we've been looking in the wrong places. Instead of distant galaxies, what if the signs of alien life are right here in our own solar system? Mars, Titan, Europa, Enceladus. These celestial bodies are more than just dots in the sky. They could be home to life forms that thrive in conditions we can hardly imagine. Mars has been the poster child for the search for extraterrestrial life. Once a wet and possibly warm planet, Mars might have harbored life billions of years ago. Evidence suggests that ancient rivers, lakes, and even oceans once flowed across its surface. These waterways could have provided the perfect environment for microbial life to flourish. Today, Mars is a cold, desert world with an atmosphere too thin to support liquid water on the surface for long. However, traces of water still exist, hidden in its polar ice caps and possibly underground aquifers. Recent discoveries have fueled speculation that liquid water might still flow intermittently on Mars, particularly in the form of briny streaks on its slopes. These streaks, known as recurring slope lineae, appear during warmer seasons, suggesting that they might be linked to subsurface water. If microbes could survive in these harsh conditions, they might still be clinging to life beneath the surface, shielded from the planet's harsh radiation by layers of rock and soil. The upcoming missions to Mars, including those aimed at bringing Martian soil samples back to Earth, could provide definitive answers to whether life ever existed, or still exists, on the red planet. But Mars isn't the only place we're looking. Some of the most exciting candidates for life are actually moons orbiting the giant planets of our solar system. These moons, with their diverse and extreme environments, present tantalizing possibilities for the existence of life. Take Titan, Saturn's largest moon. Titan is a world covered in lakes and rivers, not of water but of liquid methane and ethane. Its atmosphere is thick with nitrogen, and beneath its icy crust, scientists believe there could be a subsurface ocean of water mixed with ammonia. This strange combination of liquid hydrocarbons on the surface and a possible water ocean below makes Titan a fascinating place to search for life. It's a far cry from Earth, yet Titan shares something crucial: complex organic molecules. These molecules, which are the building blocks of life as we know it, rain down from Titan's thick atmosphere, coating the surface with an organic, rich haze. Could there be life forms that use methane instead of water, thriving in the frigid conditions of Titan's lakes and rivers? On Titan, life might be adapting to conditions that seem alien to us, but are perfectly normal for whatever might call Titan home. The upcoming Dragonfly mission, which will explore Titan's surface and atmosphere in the mid-2030s, could provide unprecedented insights into this enigmatic moon. Next, we have Europa, one of Jupiter's moons, which is shrouded in a thick layer of ice. Beneath this frozen surface lies a vast ocean, possibly twice the volume of all Earth's oceans combined. This ocean is kept liquid by the gravitational pull of Jupiter, which generates heat through tidal flexing, a process that causes the moon's interior to warm up. This internal heating could create hydrothermal vents on the ocean floor, similar to those found in Earth's deep oceans. On Earth, these vents teem with life, despite the lack of sunlight, thanks to the energy provided by chemical reactions between water and the minerals in the oceanic crust. If similar vents exist on Europa, they could provide the necessary energy for organisms to thrive, making this moon one of the most promising places to search for life beyond Earth. The planned Europa Clipper mission, set to launch in the 2020s, will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean, searching for signs of habitability and even potential biosignatures that could indicate the presence of life. Enceladus, another of Saturn's moons, is a tiny, icy world, but it's bursting with potential, literally. Enceladus shoots plumes of water vapor and ice particles into space from cracks in its icy surface, known as tiger stripes. These geysers hint at a subsurface ocean beneath the ice, and they contain a mix of water, organic molecules, and salts, all of which are key ingredients for life. The Cassini spacecraft, which studied Saturn and its moons for over a decade, flew through these plumes and detected molecular hydrogen, a potential energy source for microbial life. These geysers could be teeming with life, possibly thriving in the same way extremophiles do in Earth's harshest environments, such as hydrothermal vents or subglacial lakes. What makes Enceladus particularly exciting is that these plumes allow us to sample the moon's ocean without having to drill through kilometers of ice. Future missions could return to Enceladus with more advanced instruments, capable of detecting even the faintest signs of life, bringing us one step closer to answering the age-old question: are we alone? All these moons and planets share one thing in common: environments that, while harsh, could still support life. Whether it's the icy depths of Europa, the methane lakes of Titan, or the geysers of Enceladus, these places challenge our understanding of what it means for a world to be habitable. The presence of water, organic molecules, and energy sources, combined with the adaptability of life as demonstrated by extremophiles on Earth, suggests that these environments could harbor living organisms, even if they're not what we typically envision when we think of aliens. So, are we alone in the universe? The answer might be closer than we think. With each new mission and discovery, we get a little closer to finding out if these worlds are truly lifeless, or if they harbor hidden ecosystems waiting to be uncovered. The search for life beyond Earth is far from over. It's just beginning. As we continue to explore our solar system, we must keep our minds open to the possibility that life may exist in forms and places we've yet to imagine. If you're as fascinated by the search for alien life as we are, make sure to subscribe and hit the notification bell. We've got plenty more mysteries of the universe to uncover.